Okay, our last shape here, we have our trapezoid, opposite sides, one pair of opposite parallel sides, and we have our isosceles trapezoid, also a trapezoid, but just has some additional properties to that. And so what we know if we have a trapezoid is that our same side interior angles, because we have parallel lines, are going to add up to 180. They'll be supplementary. So these angles here and these angles over here will also be supplementary. And that works in the isosceles trapezoid as well. So your angles here, A and X add up to 180, L and E add up to 180. The additional property that you have in an isosceles trapezoid is that we have these sides here as congruent, and we also have base angles that are congruent to each other. And then angle A and angle L are congruent. Okay, so we'll use some of these properties in finding some of our angle measures here. Now, I'm going to use different angle measures from what you have on your practice test, just so you can kind of practice this independently on your own. Let's just put like 130 here for an angle measure, okay? And then we could use that to solve for angle 1 in our diagram. So I would say that 180, we'll subtract 130 from that, and that will be 50 degrees. So measure angle 1 in this diagram would be 50. Now let's just do for angle 2 here. This looks like maybe 80, we'll say. Okay, if we do 180 and we subtract 80 degrees, what we're left with for angle 2 will be 100. Measure angle 2 equals 100. Okay, now in our diagram here, I'm going to pick some different numbers from running your practice test. So let's just say that this is 42 degrees, and let's maybe say this is like 38 degrees. Okay, so first thing we know is that these base angles are the same. So I'm going to put a 38 degrees here, and I'm going to put a 42 degrees here. Okay, then we also know we have some parallel lines that are created from our Z shape. So I can make a Z parallel line. I can make a Z like this. So we've got a 38 degrees here. Undo my parallel lines, so I'm going to put my 38 here. We would also have alternate interior angles that are congruent here as well. So I can put 38 degrees in my diagram there as well. Now, in order to find the rest of the angles, we're going to have to use some triangle sum theorem properties. So I would maybe start with finding angle 4. This actually ends up being an isosceles triangle here. So I would take 180 and I would subtract the 38 and the 38 that we already have. So and that should give us an angle measure of 104 degrees. So that's going to be right here, 104 degrees, which will have a vertical angle 104 degrees. And now we can use that to help us find some of the rest of the missing angles in the diagram. I know these two angles add up to 180. So I could take 180 and I could subtract the 104, and that should give us 76. And that would go here, and that would go here. And then to find the final missing angle up here, we could take 180 and we could subtract the 42 and the 76 that we already have. So let's see. And that would give us 62 degrees. So we'll put 62 here and 62 here. All right, now for the last one here, we have some angle measures that we're going to be using our isosceles trapezoid properties. Now, I know angle Q and angle R are congruent. So even though this angle 11x plus 8 or minus 16 is labeled for angle Q, it would be the same for angle R. And we know that these two angles here add up to 180. They are supplementary. So I would go ahead and take these angles, add them together to equal 180. Once you've solved for x, you're then also finding the measure of angle P. And the measure of angle P, well, P and S are the same. So it's going to be 5 multiplied with x, whatever you get for that, plus 4.